Okay, people, graphs of polar equations. Another one, this is 9.3. And basically what we're going to do here is we're going to kind of convert between rectangular and polar coordinates and vice versa. So we're going to be given polar coordinates and we can convert them back to our rectangular XY coordinates. And then the opposite, we're going to be having regular rectangular coordinates XY and turn them into polar coordinates. So how do we do that? All right, so let's look first here, and we can say that if we have polar coordinates r comma theta, right, that's how we know our polar coordinates, then we can get xy coordinates by doing this. We can say x equals r times a cosine theta, and then y would be r sine theta. That would do it right there. Okay. If it helps, I'll just rewrite them down here. X equals r cosine theta. Y equals r sine theta. Okay. So that we would simply do it, right? You have r, you put that on top, you multiply it by the cosine of your theta here, and you should be good, and the sine of that theta to get your XY coordinates. And here's a little picture over here if you want to look at it. Next up, so going the opposite way. So this one's a little bit trickier, but we'll just kind of talk about it. And we could say that if we have XY and we want to go back to polar, we want to get our theta, then we can give these things to get them. Now r is very simple. R is just simply square root of x squared plus y squared. So that's very simple, and that'll always be your r. Now theta is a little bit different, okay? Theta is equal to, in certain terms, if this one is, we're going to use the tangent, the inverse tangent, okay, of y over x, but that is only in the case when x is greater than 0. Okay, these other ones are if x is less than 0. So in this case, one of them would be, again, I'm still going to use inverse tangent, and it's still going to be y over x. But then I would have to add pi. Okay. And the next one would be, I guess, if we're talking radians, that would be pi. If we're talking degrees, you would add 180 degrees. And so these two are when x is less than 0. So if we end up getting a negative for our x value, then we would have to do this, add pi or add 180 to it. Okay? So fairly simple there. You just got to know if do I have to add pi to it? Do I have to add 180? Or am I good to go with whatever it has? The other thing is that they're going to ask you for 2 pairs. So sometimes you're going to have to subtract or add pi either way just to get your second pair. We'll kind of talk about that when we get down to those examples. All right. One other thing to make note of is if you get say a negative y, we talked about negative x, but let's say we have a negative y here. So let's just put it, just put a star here and write it. So if you have x comma negative y, okay, what we're going to do is you're going to take the tangent, the inverse tangent of negative y x, okay, that's then going to give you kind of a negative degree, right? So what then you have to do, and this is the key, is take that negative n and then add 2 pi to it, okay? Because that will get it into our range that we want to be in. So that'll get it into this range of 0, where theta is between 0 and 2 pi. Because otherwise it's going to be negative, it's not going to be in there. But once you add 2 pi, it will be, okay? For the second value, like I mentioned, they'll have 2 points there. So for the second value, what you'll need is then, since we added 2 pi, and over here you kind of add pi, then we would subtract pi for the second value. And what does that mean? Like I said, when we get to those examples, we'll talk about what the second value is because they're going to ask for a pair, find 2 pairs. So they're going to ask for 2 of them, okay? And then I guess I would just point out, this is, when you get to your homework, this is just like number 16 and 22 on your homework on page 557. So when you get to those, remember this star here, that what you have to do. Okay, so let's get to some of the problems then. First one, we're going from polar to rectangular. So I'm just going to simply go, x is going to equal my r, -6, times the cosine of -120, which then is going to be -6 times -1/2, which gives us 3. So my x coordinate is 3. For y, it's going to be -6, my r value again, times the sine of 120, which then is going to be -6 times, I'm going to keep it in radians here, -3 to the square root of 2, which then equals 3 times the square root of 3. So my new coordinate would be 3, comma, because that's my x, here's my y, 3, comma, 3 times the square root of 3. And there you go. Okay. One thing I'll make a note here is just when you're doing this, let's just leave in the exact. So using the square roots and stuff, leaving the exact answer when a multiple of 30 degrees or 45. So if it's one of those that we know is a multiple of 30 or 45, our basic unit circle values, then leave in the exact form like we did here. Okay. All right. So let's look at 1b. So for x is going to be 5 cosine pi over 3, which is going to be 5 times 1/2. So you might need the unit circle for that. So I'm going to go with x equals 5 over 2. And then for y is going to be 5 times the sine of pi over 3, which is 5 times square root of 3 over 2. So when I do that one, y is going to be equal to, I can just multiply there, 5 times square root of 3 over 2. So my new coordinates then are x 5 over 2, y 5 times square root of 3 over 2, and there you go. Okay. All right, last one here. Do this quickly. So x we know is -3 cosine 45. Y is -3 sine 45. Okay. So that's going to be -3 times square root of 2 over 2. This is going to be -3 times square root of 2 over 2 is also. So there it is. I'm going to have my xy coordinates, -3 square root of 2 over 2, comma, -3 square root of 2 over 2. So just by using that first formula there. Now let's work backwards on these two. Okay, so find 2 pairs. So we talked about that, right? The 2 pairs of polar coordinates for each point with the given rectangular coordinates. All right, so r is pretty easy, right? So r, I'm just going to go 8 squared plus 10 squared, which is square root of 164, which is about 12.81. Okay, and now for theta, remember theta, since both of those are positive, I can go inverse tangent of 10 over 8, which is about 0.90. Okay, so my first coordinate, since I want, but I got to need two pairs, right? So my first coordinate is 12.81 is my r. My theta is going to be 0.90. Okay, but remember, I want two pairs. So here's where, if you remember, just kind of showing over here, let's say I'm at, 12.81, 0.9, right? Remember, if I go on the opposite side and use a negative, I'm still good. Okay, so that's why I would have to have another one at negative 12.81, and it would be 4.04, because remember here, I'm adding pi to get there, okay? And then here, same thing. This is 0.90 plus pi. Because remember, when I do that, I'm going 180 degrees, which is pi. Okay? All right, next one. So that's how you get your second pairs. That's why when I talked about up here, there's a little bit different when you have a negative y value. You're going to subtract pi because you're adding that 2 pi first. Okay? All right, let's try the second one. So again, r is pretty simple, straightforward to you. R is going to be square root of negative 9 squared plus negative 4 squared, which is going to be 81 plus 16, which is going to be the square root of 97. So R is about 9.85. About. Okay. For theta, now we've got theta. Now we've got x is less than 0, right? We had x is negative 9. So I'm going to go theta equals inverse tangent 4 over 9, because they're both in that, they're both negative, so I can kind of switch them. Then I'm going to plus pi, right? Because they would take a turn positive, but because it was here, I have to add this pi at the end because it was, x was initially negative. So now I get 3.56. Okay, so my first point here would be 9.85, comma 3.56. Now adding pi again because I want to get to the other side. I'm going to get negative 9.85, comma 6.70. Remember, is 3.56 plus pi. And there you go. You've got your two coordinates there when we do that one. Okay? That's all there is to it. We'll practice this as we go. And look at that time. Hey, how about that? Look at this, 13.26. That's pretty good. I have no problem with that.